Hi everyone, this is a very short video that is just going to remind you how you determine the direction of the force on a charge when it is put inside an electric field. So let's say I have an electric field, and let's say I happen to know that that electric field is directed in this direction that I'm drawing here. So this may be due to some array of positive charges or negative charges in the space that I haven't drawn, but what I do know is there's an electric field in space that points at this moment up and to the right. Now remember, the electric field is defined as the direction that a positive test charge would be pushed in. So if I were to take a charge Q and place it in the electric field, and I'm drawing it in a different color to emphasize the fact that this Q is not creating the electric field. It's not a source charge, it's a sensor charge. It's feeling the electric field. And let's say that Q happens to be positive. Well, since the direction of the electric field is defined as the direction that a positive charge would go in, that little charge Q would feel a force F along the direction of the field lines. And by the definition of the electric field, F would be equal to the magnitude of E times the magnitude of Q. And remember, we don't put signs. And so that would tell me how many newtons of force E exerts on Q. Okay, now let's say I have a different charge, and let's assume that it's small enough and far enough away from little q that they don't affect one another. And let's say this time I'm putting a little q over here, and that little q is negative. And again, let's pretend it doesn't interact with the other charge. So here's the question: what is the direction of the force on that negative charge in this electric field? Well, the electric field still points up and to the right because the direction of the electric field is the way a positive charge would be pushed at that point. And so when I put a negative charge in the electric field, if you were thinking the direction of the force is opposite the other one, you are correct. What is important to remember is that the direction of the electric field does not reverse direction. The electric field points in the same direction, but a negative charge in that very same field feels a force in the opposite direction as a positive charge would. Sometimes people like to think of it as positive charges go with the field lines, negative charges flow against the field lines. They're kind of like salmon, and they swim upstream. So to get the magnitude of F, I would again do E times Q, and if the Q's were actually the same magnitude and the E was the same value at both places, those would be exactly the same magnitude force. The only difference would be direction. Now, I don't have any way in the equation since I'm only using absolute values of charges to indicate direction, so I would have to specify with a diagram like I have done what the direction of the force on those charges is. Okay, I hope that was helpful.